There's a building so tall, it creates its own weather. Wind doesn't just hit it. Wind wraps around it, fight it, tries to tear it apart. Over 800 meters of steel, glass, and concrete, rising out of desert sand. Sand that was never meant to hold anything, let alone this. The engineers knew the risks. They built it anyway. At one point, deep into construction, something happened. Something no one talks about publicly. A problem so serious, the entire project nearly stopped. Not because of money, not because of politics, because the building itself was fighting back. This is the real story of how the world's tallest structure almost became the world's most expensive failure. The year is 2004. Dubai is building fast, too fast. The city is pulling in workers, engineers, architects from every corner of the world. And now they want something no one has ever built. A tower that breaks every record ever set. 828 meters, the Burj Khalifa. But before a single beam goes up, the engineers face their first problem: the ground. Dubai sits on a mix of sand, silt, and soft limestone. Not rock, not solid foundation, just loose, shifting desert floor. One senior geotechnical engineer looks at the soil reports. He goes quiet. His team already knows what he's thinking. This ground cannot hold a structure this size, not without serious intervention. So they drill 192 board piles, each one reaching 50 meters deep, deeper than most buildings are tall. They pump in concrete, thousands of cubic meters, creating an underground skeleton before the real structure even begins. The foundation alone takes months, and it works, or so they think, because what the soil reports didn't fully capture was the salt. The ground beneath Dubai is laced with sulfate-rich saltwater, and sulfates eat concrete, slowly, silently. The same foundation they spent months building is already being attacked from below. The engineers are informed. The project doesn't stop, but behind closed doors, the conversation changes. Because if that foundation weakens, at any point during construction, the entire structure above it shifts, and a shifting skyscraper is not a building anymore. It's a collapse waiting to happen. The foundation problem is contained, for now. Engineers redesign the concrete mix. They add special sulfate-resistant compounds. They test it, retest it, then approve it. Construction moves forward, and the tower begins to rise. But as it climbs higher, a new force enters the equation: wind. At ground level, Dubai's wind is manageable, but at 300 meters, it's a different world entirely. The wind doesn't blow straight, it spirals. It creates what engineers call vortex shedding, invisible rotating columns of air that wrap around a tall structure and push it from the sides, not constantly, in pulses, rhythmic, repeating pulses. And if those pulses ever match, the natural vibration frequency of the building, the structure begins to resonate, like a tuning fork. Except this tuning fork weighs 500,000 tons. The design team runs wind tunnel tests, over 40 different models. They try standard rectangular shapes. The wind tears through them. They try circular designs. Still too much lateral force. Then one engineer suggests something unusual. Change the shape every few floors. Rotate the floor plan slightly as the building rises. Confuse the wind. Break the vortex before it can form. It sounds almost too simple, but the numbers support it. The spiraling setback design is approved, and it works. The wind tests show a dramatic drop in lateral force. The team feels confident. Progress accelerates.
Hold steady and lower to the
Steel
guides.
goes up faster.
Confirmed.
Then, during a routine structural inspection, an engineer notices something on the upper floors. A measurement that doesn't match the calculations. By a small amount, but in a structure this tall, small doesn't mean safe. Small means the error multiplies. Every single floor above it. The measurement discrepancy is flagged immediately. A senior structural engineer is called in. He reviews the numbers twice. Then a third time, the building is leaning. Not visibly, not dramatically, but mathematically. It is not perfectly vertical. In construction, this is called deviation. Every tall structure has some, but the acceptable margin for the Burj Khalifa is razor thin, millimeters. They are already approaching that limit, and they are only halfway up. The cause is traced back to heat. Dubai's summer temperature hits 50 degrees Celsius. At that heat, steel expands, concrete shifts. The sun doesn't heat the building evenly. One side bakes in direct sunlight. The other sits in shadow. Two sides of the same structure, expanding at different rates. Every single day. This uneven thermal expansion is slowly pushing the tower off its calculated center. The construction schedule is not paused. It cannot be paused. Thousands of workers, hundreds of millions of dollars. Every idle day costs more than most people earn in a lifetime. So the engineers adapt in real time. They begin scheduling the most critical concrete pours only at night, when temperatures drop, when expansion is minimal, when the building is as close to stable as it will ever be. It buys them precision, but it slows everything down. And slowing down creates its own problem, because the project has investors, deadlines, promises made to an entire city watching from below. Pressure builds from every direction. Then, without warning, the global economy collapses. 2008, the financial crisis hits Dubai like a wave. Funding freezes, partner companies vanish overnight, and the world's tallest building is left standing half-finished in the middle of the desert. With no clear answer on what happens next, construction slows to almost nothing. The site doesn't fully shut down, but the energy is gone. Workers arrive, but critical decisions are frozen. Dubai's property market is collapsing around the tower. Buildings nearby sit empty. Developers are defaulting on loans. And the Burj Khalifa, the symbol of everything Dubai promised the world, is standing unfinished. Exposed steel at the top, open floors with no glass, a skeleton reaching toward the sky, with nothing certain above it. Behind the scenes, emergency meetings happen daily. The lead developer, Emaar Properties, is burning through reserves. They approach Abu Dhabi for a bailout, quietly, without public announcement. Abu Dhabi agrees, but there is a condition. The tower will be renamed. Originally called Burj Dubai, it becomes the Burj Khalifa, named after the ruler of Abu Dhabi, a financial rescue, written permanently into the building's identity. Construction resumes, but the pause has consequences no one anticipated. Months of exposure to desert heat and salt air have affected certain structural joints on the upper sections. Inspectors find oxidation in areas that should have been sealed, protective coatings that were never applied. Before the funding froze, remediation crews are sent up, working at heights that require specialized equipment and nerves most people simply don't have. The fixes are made, quietly, without press release, without public acknowledgement, and construction climbs again, higher than any human structure before it, until they reach a moment no engineer had fully prepared for, the very top, where the spire meets open sky, where wind speeds exceed anything tested in the wind tunnel, and where one critical installation goes wrong. The spire is the final piece, 200 meters of sculpted steel, lifted by crane in sections, each section weighing tens of thousands of kilograms, being positioned at the edge of the atmosphere, where wind gusts exceed 150 kilometers per hour. The crane operators work in narrow weather windows, sometimes only 20 minutes long. One morning, during a critical lift, the wind shifts unexpectedly. A section swings, not catastrophically, but enough. The crew holds. The operation pauses. Everyone on the ground watches silently. The section stabilizes. Work resumes. But that moment, that single uncontrolled swing, reminds every engineer on site of something important. At this height, physics has very little tolerance for human error. The spire is completed in January 2010. 828 meters, the tallest structure humanity has ever built. On January 4th, 2010, the Burj Khalifa is officially opened. The crowd below cannot see the top. It disappears into haze. But But what most people celebrating that night don't know is everything that almost stopped it. The dissolving foundation, the thermal deviation, the financial collapse, the corroded joints quietly repaired in the dark, the swinging spire above empty sky. None of it made the headlines. All of it shaped the building. Today, the Burj Khalifa stands as more than a record. It is a document of human persistence. Every problem that emerged was met with a solution. Every solution created a new problem, and somehow, they kept building anyway. Engineering didn't just construct this tower. Engineering survived it. If you made it this far, you already know this story deserved to be told.